Sorry for the delay. I'm really just getting my coffee. I really needed one this morning. But so welcome to the Extremely Open Science stream. So today we'll be picking up where we left off last week, which is looking at whether we can replace eggnog mapper or whether we can replace the KO annotations of genes that we had gotten from basically reusing the CheckM2 results with eggnog mapper. So using the CheckM2 results would have been great from a practical point of view, but as I said about 7 times in a row during the recap, better is better. So that means that if there is something that's better, even if it's a little bit less convenient, a little bit more work, better is better. So let's see if we can get that to work. So I've also mentioned in the recap and elsewhere that we are looking for new PhD students. I'm particularly looking for students that are have maybe more of a computer science or data science background that find this type of analysis that we're doing on the stream here would be the kind of thing they want to do. And if you know a little bit less about the biology and the microbiology, but that's perfectly fine. Is the volume a little bit too high? Sometimes I think in the past I've tended to have the volume a bit too low. But yeah, so if you or someone you know has a background in the more computational side of things, and somehow thinks that biology is where it's happening, it's interesting, please get in touch. So right now that's the expertise we are looking for. Again, so my group runs the gamut from bioinformatics methods development to more computational biology, so applied projects. And right now what we're looking for is someone more on the computational side of things. All right, so having said all of that, I'm going to share my screen. There it is. So let me just check where we are. I forgot to basically I didn't run all of the tasks, in this sense, I'm gonna make this slightly larger. I didn't, in this sense, the simulations, basically because I forgot to run them over the weekend. So I will do it. I'll do this week. But in the meanwhile, so what we've been doing here, let's check a little bit. So let's start a Pixie shell environment. Start a Pixie shell. And so I don't know. So there's Bacillus subtilis. This hasn't really. So this is the new thing that we have gotten this last week. All right. So there you go. Right. So the query, some hash of the query. All right. And then here's the cog category. And yep, this should work. So today I want to do 2 things. I'm gonna write them down. So one is I want to sort of reverse what we did last week. So last week what we had is, when we do the simulation, so we start with the genome, and then we add 25 mutations to that genome, and then a further 25, and then a further 25, right? And then we end up with all of these variants. But every time we add something, and here we can see I still have this here. When we add 500 mutations, we have about 1,000 genes that are changed, right? So in the sense that some of them are introduced, or this is actually not correct. But let's say I was kind of double counting here. But when you have 500 mutations, let's say we have 500 genes that are changed. That's probably more like it. So even then, most genes are common between the original and the mutated version. So what we did is we collapsed all of the, so instead of sending all of these repeated sequences, we collapsed all of them and we created this all proteins sequence and then have the hash there, right? So this corresponds to, well, this is the hash of this, and there's a table somewhere that tells me, it's going to tell me exactly where this was, all of the variants, all of the genes, all of the genomes that had this sequence, right? And so now we can reverse engineer this and now get these annotations. So that's one thing we want to do. The other thing I want to do, and actually that's where we'll start, is to interpret this, we need also some sort of background. And in the past, we've used the GMGC as the background. So we're going to do that again. So one thing we could do is we could take, so here we have, actually not the full GMGC, so the complete genome. So we could take this, so actually it's sort of sorted so that at the top we have very short sequences. So we could take this and run it through Eggnog Mapper. That would actually work. It would work quite well, but it's a lot of compute. So I want to do something a little bit. I want to do something a little different, which is I want to reuse the data. So this is, and here, so this we do provide this here. It's here. So, or actually I thought it was going to complete. Or it's also present for download here. Okay, just being a little bit slow. Downloads. There it is. Eggnog Mapper. There it is. All right. So let's get this. I don't know why. Okay. So download file. Yep, this sounds about right. So this is the first thing I want to do. I want to download the file, and then we're going to have to process this data, this file. It's going to be a pretty big file, but in the meanwhile, we will do other things. But first, we need to download it. So this will have. Yeah, there it is. So it's still downloading, but yeah, you can see here, right? So for example, this is not a complete gene, I believe. So we will have to filter this one out later. We'll have to do so we'll do a bit of filtering, a bit of eggnog annotations. Not sure. Yep. Not sure. Maybe. Let's see. I'm actually now I'm a little bit whether to be sure that this is the right versions. 2019. That was a long time ago, huh? Maybe we do need to re-annotate it. Actually, maybe we do re-annotate GMG. Maybe we end up re-annotating the GMGC and updating the online version. All right, let's worry about it later. Okay, all right, so that was, so this is, and also this is gonna take a while. Does this say how large the file is? No, it doesn't say how large the file is, but it's gonna take a little while. So oh, I forgot to add downloaded all right. Okay, I'm also rereading the notes there. So we've actually played around with some of these things. Use the dog mags. I mean, we've downloaded, we haven't actually used them. Find KOs with very stable gene sizes. We did do that actually. Look at all the KO hits. We put that diamond hits by position. So I think this just didn't work that well with that. So a lot of the explore variations. Yes, we'll have to explore variations. Okay. Okay, but while that is right. Okay, I'm gonna store that. Okay, let's see. Okay, so we have here simulation. Oh, names. Okay, I'm gonna just okay, this is there. Oh, this is a mess. This is a okay. I'm sorry. I'm sorry, guys. This is a mess up. This is actually an important mess up. Yeah, so okay, I'm gonna have to do a little bit of surgery here. The mess up here is that for some reason I had one version of the code where this collate protein sequence function, instead of returning this dictionary, or I guess what I wanted to do in my mind was I wanted to do this. That's what I wanted to do. I wanted to, so I created as a default dict, so dictionary to default, and then I wanted to return a frozen dictionary. Alas, Python, for reasons that I'm actually not 100% sure, does not include the frozen dictionary type. It includes the frozen set. I'm gonna guess that this is one of those things where if things had been done, in a more, there's some history here where the set and frozen set were introduced at one point when the dictionaries were already present from the beginning. At the beginning, back in the late or early 90s, I was gonna say, or late 80s, this immutable data was not a thing, and then by the time it becomes a thing, dictionaries are already an ingrained part of the language, and now introducing this big off-topic discussion. But Python does not have a frozen dictionary, so I somehow completed that thought and wrote frozen set, which does the absolutely horrible horrible thing, which is instead of doing what I wanted, basically what it did is it returned this that we were seeing. So it just returns the keys. So it works, it just does the wrong thing. It returns the keys, right? So I'm going to do a little bit of surgery here, which is I'm gonna just re-execute them. This should be pretty fast. Okay, I'm gonna have to probably at some point I need to clean this. I need to run everything from scratch. So I'll off stream I'll run everything from scratch. Okay. Sorry. Alright, sorry, tasks. Okay, I'm doing a lot of okay, so some of them, right. Sorry, I'm doing a lot of this jug surgery, which normally we really shouldn't be doing, but all right, perfect. This is what I wanted. That's what I wanted. Okay. Okay, I will. So the real solution for this is, when we get into the situations where part of, so what's happening here? So we have, jugs, and that's the whole point of it, is that it allows us to reuse partial results from previous runs. However, I had once the previous runs, if the previous runs are buggy, then reusing them is wrong. So what we should do actually is completely restart the whole thing, basically invalidate these results. And I think I had done that, but only for some of them. And now, at some point, and probably I'll just do that off stream. I'll just start completely from scratch. I'll basically do this off stream, where I completely erase all of the partial results and just everything computes from scratch. I'll cheat a little bit. I'll just use the HPC cluster here, so that this gets done. This gets done in a week, or if I use the HPC, it will get done in a day, because it will be able to process everything in parallel. Anyway, having said all of that, what do I want to do now? Still trying to do a little bit of surgery here. What I wanted to do is to get this. That's great. So the problem here is that the problem here is that I'm trying to use partial results, right? So okay, I'm trying to reuse these partial results when perfect, right? So off stream, I will just rerun everything from scratch, and so /to header. So this should be a dictionary, or a default dictionary. Yes, let's transform it into a dictionary. Since we're going to be rerunning everything, we might as well do it really properly. So not a frozen dictionary, because that is something that does not exist, but at least a standard dictionary. Yep. Oh, hi, Michelle. As a standard. All right. So okay, we will. Let's do. What are the keys here? I think the key should be the. So these are the number of mutations. So this is the. But the moment this is what it. Sorry, this is the wild type, or wild type, and then what I'm. Let's just read. Perfect. Does this work? Did I skip too many lines? No, this was perfect. So this is what I want to do. So this reads the eggnog mapper. Right, so what do I want? Actually, what do I want to do? So this is How do I ignore a footer? How do I ignore a footer? Sorry, I just, yeah. Okay, I'm not. So I've had people tell me that the biggest problem with polars is that all of the AI stuff. Oh, yeah. Now this is nice. Yeah, I've wondered whether we could do something like this for our tools, like SemiBin. Just have an AI chat. CSV. Okay, this works. Would this also work like this? So a little bit scattered. So what I meant. So I've had people tell me that the problem with polars is that all of the AI stuff then tries to tell you how to do things with pandas, because but yeah, so it's nice to see that ChatGPT, at least the newer versions, already says, oh, this is not pandas, and then but they do have this comment prefix, which is nice. I want to check this. I'll check this later. I've been wondering whether to, for example, for SemiBin, actually it would be nice even for us to, how the tools connect together, how you use SemiBin and with NGLS, and how you prepare the data, and maybe you want a mapping with Stroboline, and how those things connect together. It'd be very nice to have an LLM type thing for users, and so maybe that's kind of a different idea. All right. Anyway, back to where we were. Mapper out. Okay, so we have emapper out. For example, this one. Query. So this is what is this? Okay, this is a set. No, not a frozen set, but a set. So what do I want to do? So I could do this. So these are the hashes that are present in 0. And then I could take the emapper out. I could, filtering. Let's query. I think this is spelled is-in. Yeah, I could do this. Yeah, this would work. And now, yeah, this would work. And actually, even before that, probably I do want to extract the eggnog OG. Okay. Okay, so what do I want to do here? So if I had, okay, so if I had a table, basically this gene ID here, and then the eggnog OG, everything would work, right? So this is what I want. This gene ID, eggnog OG. Yep. Right, so in some ways, what I want to do is something a little bit, basically just, I actually don't know what to call it, but take the data and just reorganize it so that hash to original so gene sets, let's just call it GS in hash this work. Yeah, I don't know what I was doing here. Okay, and if this works, then the hash to original of this thing will include this one. It'll be a big list, but yes. Okay, so this is so this works. So now if I have hash to original, okay, so we have all right. So now we have the emapper outputs, right? Again, so this sequence with this hash has, this classification, and we can map, and we have the original, and we have this other table that original. Actually, we should. All right, let's do it this. Instead of the dictionary is nice, but we should. Let's do a list. And the reason I'm doing a list, even though that one was better, schema hash original. All right, perfect. And now sorry, polars. Seed right on hash. Query, not seed query. Perfect. Yeah, this is what we wanted. Okay, so all right, so we are. Okay, this is actually quite nice. Okay, so today because we were kind of we hadn't had the results from the previous from last week. We're still running. We are doing this a little bit differently. So normally I've been using NeoVim as my IDE and then coding within it. Today we just did everything on the IPython shell. Actually, I used to do a lot of work like this. Before NeoVim existed, actually, to be honest. Okay. All right. So what I wanna, all right. So I just wanna clean up a little bit. Move this code. Actually, I don't even know where I want this code because, frankly, but yeah, I don't. Mapper out. Yeah, I still don't even know where I want this code because frankly this probably should be part of a bigger function which we have not yet written. Okay, what I'm going to do here, I'm going to restore, so I'm going to throw away this code here. So as I said before, we've let this get a little bit out of hand. I probably if I was doing this for real, I would have, I would have sort of done this, put it on the cluster, and then this will take a few hours, and then we'd work with clean data instead of having to do this ugly surgery here to work, which I frankly really don't really like. Give me a second. And I'm back. Yeah. So which I don't really like this. So all right. So where are we? We have about 15 minutes. A little bit less than that. So let's wrap up. So let's see. We're downloading the data. That is good. Okay. Download GMGC v1 upper annotation. Okay, so this is done. And then here, everything's a little. Run emapper. What does emapper return? Out here. Okay. Okay, so this is just for me, it's not clear whether I will want to have this as something that we run from scratch every time, or whether and hash to headers. So this is seg maps. It's not that. All right. All right. So we can't really use this code because this code is gonna depend on other things. Right. So what I'm gonna do. Oh, this is not. Sorry, I try to use this a large font so that this is readable on the stream, but sometimes it's a bit too large. So what I'm gonna do, right, I'm gonna do this. Start from scratch. Had already. Oh, there's also a check file. What is? Oh, no, this does not. Just August 2024. Yeah, let's remove this. Okay, we did run this as a separate thing. So let's keep that as a separate thing. And now, okay, this is now gonna have to be right. So the thing about yeah, so sometimes we just need to. Oh, that was without finish downloading the other code. So that's great. So that's. At least that's done. We will have. We can let's look at it a little bit now, and then expand the progenomes. Okay, I'm gonna make a very small change here, which is. make a small change here, which is, so if this, so if the file already exists, let's not re-expand it. So I'm going to make things a little bit faster. Also, I'm not sure if it, to be honest, maybe it doesn't make a big difference, but let's just avoid work. Genomes. Although since we are in this mood to and this it's just, why not? Let's just remove it, clean everything up. Well, the one thing we shouldn't have done actually is, so the outputs, so let's remove the ones from simulations because that's fine. But the other ones actually we want to keep at simulations. What is this one? Oh yeah, let's keep that. All right, and yep. So this was a, yeah. So we've cleaned up the. It's had gotten a bit too much. Yeah, I didn't like that we were doing things, a lot of surgery of trying to reuse part results from code that was the buggy version of the code. So we were working around that, and yeah. So this way everything is fine. So what I'm gonna do, so this join emapper code, I'm gonna leave it as a separate file. So this is actually something, so I'm gonna put it in the work in progress file. So how we do that? Okay, node stream clean all files. Run. To okay, so that one will go into the, okay, so let's do this. Okay, so this goes into main, the stream nodes, document stream progress, and now let me see where I am. Yep, I'm gonna switch to work in progress branch, rebase onto main, merge main, this work, sorry, yep. Go to map, so it's to, yep, to, well, I was gonna say undereplicate, but it's to undereplicate. Yeah, I mean that's, which is the same as replicate. But if I said to replicate the result, sounds weird. Emapper results. Okay, so push. I want to push everything. Yep, pushed everything. Right. So there it is. So yeah. So everything as usual is on GitHub. So as you just saw me push the results there. So please, please go there if you want to find this. I'll be posting on the mailing list. So I'm going to be rerunning everything a little bit. Do a tiny amount of cheating, which is I'm going to run this on the cluster so that things are going to finish. And I will do a recap video later in the week where I show you those results. But in the meanwhile, everything Everything's on GitHub. There's a mailing list. I'll post on the mailing list once I have those updates, and I'll post on the mailing list when I have those updates. Again, we are looking for PhD students, so especially people who are coming from the computational side but would like to learn biology. Please get in touch. Email me if that's you or someone you know. So in the meanwhile, have a good week and